Yeah, thank you very much. I'll switch language now because, there is an international audience here, at least in part, and it is a topic I always only ever think in English about, so I hope that's okay. There is, of course, translation if need be. So I would like to start with sort of two things. When we talk about climate change, or when we read about climate change, particularly in the news, in media, but also when we have the big climate conferences every year where all the countries come together to discuss the future of the climate and the future of climate policy, climate change is still mostly talked about as something in the future, as something that will be a big asteroid or whatever falling onto us if we reach a certain temperature threshold, like 1.5 degrees or 2 degrees. But of course, that is not the case. Climate change, and this is why I have this YouTube video from a colleague from Berlin, Climate Adam, who explains climate change in YouTube videos here, who explains very nicely, climate change is not a bomb that will at some point explode, but climate change is something that has started a long time ago. It has started when we started the Industrial Revolution, when we started burning fossil fuels, and over the last century, we see more and more greenhouse gases in the atmosphere, and that changes over time the climate and weather on this planet. So we are long in the era of loss and damage. Climate change is not something that will happen in the future to some other people, to just future generations, or to someone else. But climate change has happened over the last decades, and of course we have sped up burning fossil fuels in the last decade, so climate change has increased in how it affects climate and weather around us. But it's not that when we reach 1.5 degrees, suddenly some cliff will appear that we fall off. It means for almost all the impacts of climate change and all the ways of how climate change manifests, that it will get worse the hotter it gets, but it will get a bit worse with every 1/10 of a degree of warming. There is no threshold in which suddenly something changes. So we will not notice. And even when you think about tipping points, they are tipping points that change fast on climatological timescales. But they don't change fast on human timescales. It's not something that we will notice that we have reached a tipping point. And I think this is really important when discussing climate change, when thinking about climate change, and also especially when talking about climate policy, whereas most of the discussions and most of the political decisions are still only about mitigation, so stopping to burn fossil fuels. And of course, that is crucially important, and climate change will get worse and worse and worse as long as we keep on burning fossil fuels. But we cannot just focus on the future and just on mitigation, because we already have climate change and we already have 1.2 degrees of global warming, and that has altered weather and climate around the world. And I will now, the main part of this talk will be about how we know that this has changed and what that means for different parts of society. So we already talked a little bit about it in the discussion with Wolfgang just now. Climate change can affect weather in two ways, basically. Because we have more greenhouse gases in the atmosphere overall gets warmer. That means, on average, we see more heat waves, fewer cold waves. Also, a warmer atmosphere can hold more water vapor. That needs to get out of the atmosphere, and it does that as extreme rain. So also, on average, we see more extreme rainfall. But there's a second effect, and because we have changed the composition of the atmosphere and the temperature differences in the atmosphere, that means we have altered the atmospheric circulation, which means how weather systems develop, where they move. And this second effect can either be in the same direction as the warming. So because of the warming, we see more extreme rainfall, but we also have more low pressure systems that bring in rain into the atmosphere. And so we have even more extreme rainfall in a certain part of the world on a certain season than we would expect just from the warming. But these two effects can also go against each other. And you can have, if you don't get any weather systems conducive to rain, you can expect as much rainfall as you want from the warming, you will not get it. Because these two effects always work together. And so it can be that there is, in a certain season, in a certain region, a drying effect. And so because these two effects work together, we don't necessarily know, just from the overall understanding of the large-scale physical processes, how weather is changing locally. And there are also lots of other local factors playing another role. And so this means weather events can be made more intense and more likely, or less intense or less likely, or not change in their intensity or likelihood because of climate change. But very, very rarely you will have the climate change is the only reason for an event to occur. So when we want to know what the role of climate change is, to ask, is this climate change or not? That is not a question that you can answer with yes or no. It's the question that we can answer is, what is the role, or has climate change altered the likelihood and intensity? And now we can also answer this question. We can not only ask it for a lot of different types of extreme events. And the way we do that is by finding out what is possible weather in the world we live in today. So we just mentioned the heavy rainfall event in Germany, Belgium, and the Netherlands last summer. So when we want to know what's the role of climate change in this, we need to find out what's the likelihood of, or what is possible extreme summer rainfall in this area in the world we live in today, with 1.2 degree of global warming that we already have. And then we might find that, as was the case for this rainfall, it's a 1 in a 400-year event in the world we live in today. That doesn't mean that every 400 years we'll have an event like this. It just means that in any given year, in any given summer, we have a 1 in 400 chance of such a heavy rainfall event to occur. And we know that because we have observations of weather, and we have climate and weather models with which we can simulate possible weather in a given climate. But this, of course, only gives us the world today, where we do have climate change already happening. But we do know very well how many greenhouse gases have been put into the atmosphere since the beginning of the Industrial Revolution. And so we can take these out of the atmosphere of climate and weather models and then simulate what is possible weather in the world that might have been today without anthropogenic climate change, so without human-caused climate change, without the greenhouse gases from burning fossil fuels. And as you can see in this schematic here, you will then maybe get a very different distribution of possible weather in a world without climate change. And because the only thing that is different between these two worlds that we look at, the possible weather in the world we live in today, possible weather in the world without greenhouse gases, we can attribute the change in the likelihood and intensity of extreme events between these two worlds to climate change. So we can say, and this is what we found in the case of the rainfall events in Germany and Belgium and the Netherlands last year, that because of climate change, the likelihood of such an event has approximately doubled. That means it's still a rare event. It's still only a 1 in 400-year event. But without climate change, it would only have been expected to occur about once in 800 years. So that means climate change does play a role, but is absolutely not the only thing that plays a role. Even without climate change, there would have been an extreme rainfall event, and there would probably have been lots of damages. But climate change adds to the intensity and therefore increases the damages of these kind of events to occur. And that's a very typical example of how climate change interacts. There are some other examples of different kinds of extreme weather events. So last year, and I'm sure that most of you also remember this event, so last year there has been a really dramatic heat wave in Canada and northwestern US, where the previous temperature records were broken by almost 5 degrees Celsius. So it was really a heat wave that was well beyond anything that anyone has ever experienced in that region. And that was, and you can see on this map here where the region is. So it was around Portland, Seattle, Vancouver, so these last cities in the western part of North America. And that's an event where climate change really was an absolute game changer. So it's still a rare event in the world we live in today, but without climate change, it would have been basically impossible to ever reach temperatures as high as have been observed last year. So this is one of the few examples where you could actually almost answer the question with was this climate change with yes or no, and in this case, yes. But this is a very extreme example, and we will only ever see this for heat extremes. All other types of extreme weather events, heavy rainfall or droughts or tropical cyclones, there you have changes that are on the order of maybe doubling or no change. But for heat waves, climate change really is an absolute game changer. And when we think about climate change, or when we talk about climate change, and when we read about the impacts of climate change, quite often it's not about heat, but it's about droughts or things like that. But actually where we notice climate change the most, and also where it kills by a large margin most people, is through the changing likelihood and intensity of heat extremes. And so this is one example where this event would not have occurred in this way without climate change. But, and this is really important, not all extreme events are being made worse by climate change. And climate change is not always a cause or even an important cause in extreme weather events. So this was one that you probably also have heard about in the news, because the head of the World Food Programme said last year that this drought in southern Madagascar that has led to famine and food insecurity in the region was the first completely climate change-induced drought. But that is actually not true. It's a region in the world that has extremely high levels of poverty and huge dependency on the natural variability of weather. So there's a huge dependency on the rains in the rainy season to be there. But also without climate change playing any role at all, they just don't do that. They are not there every season, every rainy season. So there are, just from the natural variability in the climate system, there are years with very little rain. And so the last 2 years was one of these 2 years, two after another, with very little rain. But climate change actually did not alter the likelihood. And also, because it's an already semi-arid region, the temperature changes that, of course, did occur, did not actually do anything to the drought. But that doesn't mean that, of course, that this drought is not important or that it doesn't have any impacts. In the contrary, it means that the very high levels of vulnerability, the fact that there is this huge dependency on rainfall, that there is no security system to help or to offer farmers in the area any other kind of income so that these dependencies on the rainfall can decrease over time, means that in future worlds, this vulnerability will still be there. And so no matter what we do in terms of climate policy, and if and when we will stop burning fossil fuels, these dramatic droughts, where we are not even adapted to the climate of today, will still be there. And so this means that instead of blaming this on climate change, which then takes all the agency away from locally addressing the factors that lead to the impacts, the vulnerability, the poverty, means that cannot be addressed. And so this is one example where it's really important also to find that climate change does not play a role, because it means that we actually have the agency, we have all the knowledge, it's not something that is taken away from locally and the reason caused by any kind of big climate change monster, but it is something that is because of the natural climate variability and that need to be addressed locally. And that is as important as finding these other types of events where climate change is an absolute game changer. Because we can't play these different sources of inequality, these different sources of vulnerability against each other. But if we actually want to live in a world that is resilient to climate change, these inequalities need to be addressed locally. So these kind of studies, this one where we found that climate change did not play a role, the other one for the heat wave where we found that climate change was a real game changer, and lots of other studies have been done sort of over the last 10 years, more and more, and 10 years ago it was something where we had maybe 1 or 2 studies in the world, but now we actually have many studies, and so we are beginning to get an overview of how climate change actually affects different types of extreme weather events. And so the last IPCC report that was published last summer in August is the first IPCC report that really actually says something that you could say is close to having an inventory or having an idea of what climate change means in different regions across the world for different types of extreme events. And this is sort of the overview result of assessing all the published literature on different types of extreme events. And here you can see the results for heat extremes. And every hexagon is a region of the world, and the red hexagons are those where heat extremes have already increased, and where you see the number of dots shows you how much confidence we have that the increase we observe is because of climate change. And you can see that in almost all parts of the world, we do see an increase in heat extremes, and we do know that it's because of climate change. So when you talk about heat waves, you actually don't really need to ask the question, is climate change a factor? But you can just ask the question, how big a factor is climate change? But that is different for different types of extreme events. So this is the same thing, but for heavy rainfall. And here in green, we see where heavy rainfall has been observed to increase. And you can see that this is not everywhere in the world. This is in large parts of Asia and Northern Europe and some parts of North America. But also, and that's really important, there's this huge part of South America and also Africa where we have lots of gray hexagons. And the gray hexagons mean we do not have any literature or any observations that allow us to assess how extreme rainfall is changing. So while we do know a lot, and our knowledge has increased dramatically on the role of weather and climate over the last 10 years, we don't know everything that we want to know, and we don't know everything that we need to know to really know what we need to target our adaptation efforts to. And these large areas of the globe where there's no scientific literature and this is what the IPCC does. So if there is no scientific literature, the IPCC reports cannot say anything, because it's the mandate of the IPCC not to do new science, but to assess the science that is out there. And so this is a really important gap, and it means that, for example, we do have in the Paris Agreement a target on adaptation, but that target on adaptation at the moment is not in any way quantitative. It doesn't really say what we should adapt against. And when we try and find out, okay, what is actually happening, we see that in large parts of the world we don't know that. We still don't know that yet, even though we now have the tools and the science to address that. And so there is still a very large capacity gap in big parts of the world where we haven't figured out what the different drivers of extreme events are. We do know a little bit more, though, than is in the IPCC report. So this is a similar kind of map put together by Carbon Brief, which is a climate and energy news outlet in the US that reports on climate science. And this has put together an overview of all the studies on attributing extreme weather events to climate change. And you can see there are more and more studies coming in, so because the literature in the IPCC report is already a bit old, so when we assessed the literature and saw that there is a big gap, of course people have started to fill these gaps. But this is, and you can also see that here, everything in red is where climate change does play a role, and blue is where climate change does not play a role. But this is, of course, not representative of the types of extreme events that are happening. This is the things that we study. And scientists do tend to sit in Europe, in North America, in Australia, and do tend to study what's happening in their backyard. And so, when we read about extreme events, and when we read about these kind of scientific studies, we get a very distorted picture of what climate change actually means and what is happening. And I have tried to figure out how large is this discrepancy between what's actually happening and affecting people, and what do we know. And so the result of this attempt is on this map, where in red, the red circles represent death from extreme weather events over the last 15 years, in different countries. And the larger the red dot, the more death from extreme events, and the circles are all on the capital of the state. So you can see, for example, there's over India, there's this huge big one, which is actually not India, but it's over Myanmar. That's death from a very fatal tropical cyclone. You can see over Moscow is another huge red circle, that's heat wave death. And then I have overlaid these deaths with black circles that represent death from extreme events where we do know the role of climate change. It doesn't mean that all the black ones are because of climate change, but we do know what the role of climate change in the weather was. And you can see for Moscow, for the heat extremes, we do know that. But for the tropical cyclones that devastated Myanmar, we don't. And for lots of other countries, particularly in the global south, we don't. But these deaths, and I use death not because I'm particularly morbid, but because it's the kind of measure of impact from extreme weather that you can best compare across the world. Because if you would use something like economic impacts, you would always have the US on top, because they have lots of insurance, they have a lot of very, very expensive kit standing around that's hit by extreme rainfall events, and therefore have large economic losses. But of course, the economic losses are much smaller in developing countries, so this is not a measure that you can really compare if you want to try out what the impact of extreme weather is on people. But these deaths are only the ones, of course, that we know of, that are reported, and that are in global databases of disasters. But not all extreme events are in these disaster databases. And so this is a map of heat wave impacts globally. And everywhere where there's gray and these circles, these show heat waves, instances of heat waves that have occurred in different countries and affected people. And when you look at Africa, you see that there don't seem to be any heat waves in most African countries. That's of course not true. When you look at observational data, you see that actually Western Africa, but also Southern Africa, is a hotspot of increase in heat waves because of climate change. But these are not recorded. There's no heat wave warning. The local Met services don't measure heat waves, we have no connection between heat waves and the impacts of heat stress on people. So there are lots and lots of where we know academically, scientifically, that climate change is taking a huge toll, but we have no numbers. It will never hit any newspaper. It will never hit any NGO report, because there is no awareness that heat waves are actually happening. There's no awareness that heat waves are, at least in all the countries where we have data, the deadliest extreme events. So there's still a long way to go from where we are now to truly understand what the toll and what the true cost of climate change already are, let alone in the future. And that is really important when we read the news, write the news, do decisions, make decisions on local adaptation, local resilience building, think about how to provide developmental aid, what to invest in, to keep in mind that we really have a huge underestimation in all the data that is available on what the impacts of climate change today actually are. And when we look at maps like this, where it says, or not maps, statistics like this, which the cost of extreme weather events are rising. And a lot of people say, oh, this is because of climate change. Of course, this is not just because of climate change. This is also because there's more important, not more expensive things being built in flood areas and so on. So there's a lot of other factors playing an important role. And we do now have, in theory, the tools to disentangle or to work out how much of this is because of climate change. But we haven't done it, and we haven't built the databases and the inventories that we would need to actually do this globally. And I think this is a problem because potentially we really severely underestimated. So this is just one example. Hurricane Harvey hit Texas in Houston, Texas in 2017, caused huge damages. And based on several attribution studies, economists have calculated that of the $90 billion damages that the hurricane overall led to, 67 billion are because of climate change, because of the increase. Even if the increase, though the increase is relatively small, it's about 15% more intensity. But of course, these 15% make a huge difference in damages. And when you then compare what the large global economic models that are usually used to predict or project the impacts of climate change, they project $20 billion for the whole year of 2017 for the whole of the US. And of course, not every year is a hurricane like Harvey, but every year there are a lot of extreme events hitting the US and causing damages. And so this is an example of we could really do a bottom-up calculation of what climate change costs, but at the moment we don't. But it shows that climate change is potentially a lot more expensive than we usually think about and then we usually quantify. And therefore, when we think about or when we read about, oh my God, climate mitigation is so expensive, we don't actually have the numbers to say, well, it's much, much more expensive to not do anything. But we do know that it is that. And I think, so all the economists around you here, maybe if there are any, I think it would be really important to do this more and to actually build these inventories so that we can have a better and more complete picture of what the role of climate change is, how much it costs, but also what is not climate change, what damages and things that are occurring can we address locally that are because of local vulnerability, building houses in the wrong places, and so on, so that we can stop playing one thing against each other and having doom scenarios, but try to understand and address climate change in the messy way it affects the world, in this messy world we live in, even though that is maybe not quite the snappy headline we would like to see. Thank you.